Well, hello again. I wanted to record a quick video tonight. I've been traveling for a good chunk of today. I'm in a hotel in Las Vegas for the AWS reInvent conference, and I just have a few minutes before I go to bed. I wanted to record a video showing what I did on the plane ride over to Las Vegas from Oklahoma. And I did actually a few things. I was going to show symbols, but I think I did a few more. Let's see, what did I do? Yeah, so I added the kernel module since we added module support the other day. I went ahead and pulled puts and print out of the object class and put it in the kernel module, which is then mixed into object. And so it's a little bit more tidy, and it's basically what Ruby does. And I fixed object inspect. That was just a minor thing. And then I implemented symbols, and these last commits are all about symbols. And so I thought I'd go over that. Maybe not every line of code, but just to show the big parts of it. I wrote a very simple test for parsing symbols. It parses a lowercase symbol name and an uppercase symbol name. I don't think I've ever used an uppercase symbol in Ruby, but it is supported. And so it just parses just like that. The parser is very simple. It essentially just looks for a colon followed by an alphabetic letter. Yeah, not alphanumeric, just alphabet, and then followed by alphanumeric. But it has to start with a letter, and then it can have letters or numbers after that. Oh, and I just realized there's a bug. Well, let's go ahead and fix that. But let's do it test driven because because symbols do support underscore. So let's just do foo and bar and watch it fail. And yeah, so glad I was reviewing this, so I caught that. There we go. Yep, this failed. It did not know what to do with the underscore. So let's run it again, and hopefully that'll be good to go. Okay, awesome. Let's commit that. Yep. Allow underscore in symbol name and push. Cool. Code review, yay. So that's where the parser is. The compiler, oops. The compiler looks something like this. When it gets a symbol, it just writes a little bit of C code, nat symbol, passes in the environment and the name of the symbol. And the way that works is if I go to nat symbol, this is a little bit different than like a number or string because we want a global list table of symbols. So in Ruby, if I have foo and its object ID, and I do it again, it's always the same object ID because it is the same object. So even though I'm calling it more than once, it's always using the same symbol. Compare that to a string, which is going to create a new string every time, and these are different object IDs. So in order to implement that, I did a symbol table on the environment, and I'll go ahead and show that. Natalie H. Here's the environment. I added a struct hash map pointer to symbols, and it's a pointer because I want every environment, even children environments, to have the same symbol table. So they all point at that same struct. And where we create that is nat build env, I believe. Nope, build env. I just realized that's not prefixed with nat. I need to fix that. But here we if this is a child environment, then we just copy the pointer. If it's the parent environment, then we go ahead and allocate memory for the hash map. And I didn't really explain, but I'm using a hash map library that I did not write. Someday I might be ambitious enough to write my own hash map library, but this one's MIT licensed, uh, and it works really well. It's very simple. I can understand mostly what it's doing. So I've been using that all over the place in Natalie. And here it just allocates that, stores it on the environment, and so now it's available everywhere. It's essentially global to Natalie, and any function can use it. So if I go back to symbols over here, nope, yep, Natalie symbol. So what it does is it looks up to by name the symbol. If it exists, then it just returns it, and if not, then it goes and creates it. Nat new creates a new symbol with a class of symbol. It sets the name. It puts it in this symbol table, uh, and it returns it. So it's pretty easy. Let's just take hold on. Let's just look at that again. Was there anything else interesting? Pretty simple stuff. It was just a lot of busy work, just um, setting all this stuff up. I did implement object ID so that I could test that it was doing what I expected it to. And Natalie, and if I do food object, I think this works. Uh, and then food object ID again. Um, this just returns a pointer to the memory. This doesn't really look like Ruby's object ID, which is just a number. And I'm not sure how they get a number out of that. I was unable to. So if I do foo, if I just do object new, then this looks a lot like my memory pointer. But if I do o.object ID, then it's an integer. And even if I convert it to hex, it doesn't look like this. So I need to figure out how they're getting this really big integer. Um, yeah, I don't know where this object ID is coming from. If it's not a pointer to memory, then maybe it's just an incrementing number, but why is it so big? Anyway, lots of questions. I'll come back to that later. For now, our object ID just returns a pointer to the memory as a string, and that's definitely going to bite me because in Ruby it's an integer. So I'll come back and fix that at some point. Let's see, what else did I do? Implemented symbol to as, symbol inspect, so that they can actually show in the REPL. That stuff I already showed you, and that's it. So overall, not too bad, not too hard. Um, let's get out of this, and pretty happy with it. So next, tomorrow night, what I want to try to do is true and false, true class, false class, that sort of thing. And man, we're making some progress. So if we get that, then we can do equality checks, and the sky's the limit. After that, I think would be if and an if statement or if expression, I guess, uh, and some while loops. And I've got a whole list of things I want to do this week while I'm at this conference. So in my downtime, I'll be working on that and hopefully making a video every day that I work on it. If it's something interesting, if it's something just minor, then I may not make a video for it. But anyway, that's it for this one. I do want to say that I realize no one's probably going to watch these videos other than me, but I really hope that Natalie someday is a real language that people can actually use. And I think it's just cool to document the process and the steps that I've gone through, and to show, I mean, for me, to document it for me, but also to show that anyone can do this. If I can do this, I don't have any formal training or really experience doing this. If I can do this, then you can too. And I hopefully am showing that this isn't hard. This isn't super difficult. I used to think writing parsers and interpreters and compilers, I always thought that was really hard. And so I'm starting to realize, like, it's a good kind of hard. It's possible and it's fun, and you can do it incrementally and just do the things that you think of as you go. You don't have to imagine the whole thing all at once. You can just bite off little pieces and do them one at a time. So hopefully I can show that to you guys. Thanks for watching, and I'll see you next time.